Okay, since we've been discussing ionic compounds, an ionic compound is a compound between ions, between cations and anions. Cations are positively charged, anions are negatively charged, so they will be attracted to each other just like a magnet. Cations are mostly formed from metals and anions are formed from nonmetals. So we could also say that ionic compounds are between metals and nonmetals. So here's what's going to happen for an ionic compound to form. Lithium we know has 1 valence electron. Fluorine we know has 7. Remember, the magic number is 8, like the noble gases, so fluorine only needs to gain 1. Lithium is much happier to lose its 1 electron, so lithium will actually lose its electron to fluorine, making both of these stable. That's how we get the ions, lithium plus and fluorine minus. Okay? When this happens, the cation and the anion are going to be attracted to each other, forming the compound. To come up with the chemical formula, we look at how many of each atom was needed to satisfy their octets, to satisfy their stability. So we have 1 lithium, 1 fluorine needed. Both are now stable since lithium needed to lose 1, fluorine needed to gain 1. So the formula of this compound would be LiF. The cation always goes first, the anion would go second. If we look at another example, we use lithium again, but this time we have oxygen. Lithium still only has the 1 valence electron, however, oxygen only has 6 valence electrons, which means it needs to gain 2. Lithium only has 1 to give. So lithium can give its 1 valence electron to oxygen. Lithium would be good because it lost its 1 electron. However, oxygen needs to gain 2, not 1. So it is not yet stable. It's not yet happy. So when we're talking about compounds being formed, we have to realize that atoms are so small that we have to have a large amount of them. We're not going to have just one lonely atom reacting with one other lonely atom. We have a bunch of lithiums and a bunch of oxygens. So what would actually happen is another lithium would come and say, oh, I have a valence electron that you can have. And now this lithium is satisfied, and now oxygen gained 2 electrons, making the octet 8, so now oxygen is satisfied. The formula for this, because now there's 2 lithium atoms, we would say, okay, we have lithium, but we have 2 of them. So we use a subscript to show that there are 2 lithiums. And oxygen, of course. We don't have to write a 1 for oxygen. When there's no number there, we understand it to mean 1. However, I erased too much. For lithium, since in this case there are 2 lithiums, we do have to specify that there are 2 lithiums to make it stable. If we look at another example, these are just between elements X and Y. They're just arbitrary elements. Element X has 2 valence electrons this time. Element Y, meanwhile, has 1, 2, 3, 4, 5, 6, 7, only needing to gain 1. So, gains 1, Y is happy. However, X needs to lose 2, not 1. So in the same as the lithium and oxygen example, we would have more than just 1 Y atom. So we do have another Y atom that can take the other valence electron. Sorry, I was having issues with my pen. So it can take the other valence electron. Thereby that makes that Y stable, and now X is stable. It lost its 2. So the formula between these ones, we only have 1 X, so I just have X. But now I have 2 Y's, so X, Y, 2. And that's how you come up with the formulas for ionic compounds.